right, folks, are you ready to learn how to graph sine and cosine curves? It's gonna be fun, let me tell you. Okay, so first of all, when you go to sine or graph y equals sine of x, this is just going to be the very basic parent graph of sine of x. And of course, we're going to be able to do all sorts of different things to it, stretch it, shift it around, up and down, all sorts of different things, change the period and amplitude. And what we're going to be concerned with mainly is, can we label these axes correctly? So when you go to first graph your sine curve, we're going to draw an x and y axis, but we're going to make this x-axis really long this way, and then the y-axis up here kind of shifted over to the left a little bit. And this is because we typically graph our sine and cosine curves on the interval of 0 to 2 pi. Now that could change, and if it does change, the book will tell you, or the problem will tell you what interval to graph it on. So you do have to pay attention to that. But for our purposes here, where we're just basically learning the logistics of this, we are going to simply go from 0 to 2 pi. So when you go to label your x-axis here, what we're going to do is we're going to pick some point out here, wherever you want it to be. It could be over here, it could be all the way out here. I would try to make it as big as possible so that we can see what's going on. And you're going to put your first line that you have here, and we're going to call that 2 pi radians. And that is going to mark off the end of our graph. Okay, so our graph is going to start at 0 and go all the way to 2 pi. Now, this distance that you've created here, we're going to cut that in half again, and half of 2 pi is pi. And then of these two distances that are now created, we're going to cut those in half. So that's going to be pi over 2, and when you cut this in half, this is 3 pi over 2. So if you look at this, each interval that we have here is pi over 2 units, or pi over 2 radians, right? And if you notice, pi over 2, pi, 3 pi over 2, and 2 pi, those are your quadrantal angles. So if you have your unit circle with you, next to you, you can take a look at the values of sine at each of these values, at each of these angles. So when we go to first plot our points, when you look at your unit circle, at 0 radians, sine is 0. So we'll put a point right there because it's at 0, 0. But then if you move all the way up to the pi over 2 radians, you'll notice that sine is now at 1. So we'll put a point right up there. And then move along your unit circle over to the pi, and you'll notice that sine is back again at 0. So we'll put a point back here at 0. And moving along down to 3 pi over 2 radians, sine is now at -1. That's about right there. And then back up to 2 pi, we're back at 0. Okay. Now, if you looked at, pi over 4, at pi over 4, you're at root 2 over 2. At pi over 6, you're at 1/2. So you can kind of, if you plotted this, kind of like right here, and then here, if you looked at those and you tried to estimate it, you can kind of see this curve that is created. Oops, it's really hard to draw this with the computer. But once you reach up here, then you start going back down to the pi, and then we come down here to the 3 pi over 2, and then back up to the 2 pi. And that was really poorly drawn, but it's a computer. What can you do? Anyway, that is the basic sine curve. So what you need to remember is that sine typically starts at 0 at the origin, goes up to 1 at the first quadrantal angle, then down to 0, back down to -1, and then back up to 0. Okay, so that's sine x. So let's clear that and move on to cosine. Okay, so y equals cosine x. So I've already established these 4 markers here. I'm going to go ahead and put my 4 quadrantal angles in there. And referring to my unit circle once again, if you look at 0 radians, cosine is now 1 instead of 0. Okay, and then at pi over 2, cosine is now 0 instead of 1. So it's backwards from the sine curve, isn't it? Okay, at pi, I'm down at -1. At 3 pi over 2, I'm back up to 0. And then at 2 pi, I'm up at 1. So if you're not careful, this could end up looking kind of like a V. Looks exactly like a V if we did straight lines. But remember, this is a curve, and these should be kind of rounded. Okay, so you're going to do your best to make this a rounded, so we have like a valley, and we have a hill, like that. Ooh, that was much better than sine, wasn't it? Okay, so that's what cosine looks like. So what you need to remember is that cosine is going to start up at 1, go down to 0, down to -1. Ooh, look at that. Bye-bye. Down to -1, back up to 0, and then back up to 1. Okay, I need to pause this for a second. All right, I'm back. Here we go. So the next thing that we're going to do is we are going to continue this curve off this way. So if I put this next line over here in the negative sign, that's going to be a -2 pi. And if you follow how this curve is going, you should anticipate that it should be starting to go back down here a little bit, right? So I could continue drawing this like that. And then I know that it would continue on if I really wanted to off the screen. So what we can take from this is that our curves, our sine and cosine curves, they're really never ending. They just keep going up and down like a big wave. And so when we are graphing, we are only graphing a small, short little interval of that curve. So in this case, from 0 to 2 pi, or from -pi over 2 to 2 pi. Okay. Next, what happens if I put a 2 that's multiplied to the cosine of x? So the 2 is in front of our cosine x. Well, what that means is that each of these points, actually, in fact, all of these points here, but we're going to use these quadrantal angle points, are going to get multiplied by 2. And that's going to change the shape of our graph. So if this value of 1 gets multiplied by 2, that's going to go all the way up here to 2. But 0 multiplied by 2 is still 0. And then -1 multiplied by 2 gives us a -2. You can kind of get the idea of what this will look like. 0 multiplied by 2 gets 0, and then 1 multiplied by 2 is 2. Okay, so if I were to connect the dots now, probably not going to be as nice of a curve. Not too bad. That one was horrible. Okay. Well, you get the idea, right? So what it did is it took all these points, the ones and the -1s, and it basically stretched your graph up and down, whereas the zeros stayed where they were. Interesting, isn't it? Okay, so let's erase all of that and move on to the next slide. All right, so here's another one that we're going to have to graph. It says y equals a -2 sine x, and our interval now is from 0 to 4 pi. Okay, so what you can do is you could mark off, the first 4 points as your 4 quadrantal angles, pi over 2, pi, 3 pi over 2, and 2 pi. And then with that same equal spacing, continue on another 4, because you're going to go another 2 pi, right? Because you're going all the way out to 4 pi. When you go to mark the second set of 2 pi's, I only need you to give me this middle one and this ending one, but you still need to have these markers there, right? You do still need to have the first entire rotation around the circle, the unit circle, these 5 points here when you go to graph it. Okay, so let's see here. Now sine normally starts at 0, and 0 multiplied to a -2 still gives us 0. Okay. and sine would normally have gone up to 1, but we are multiplying that by -2. So instead, it's going to go all the way down to -2. Okay, and then it would go back up to 0, because 0 times -2 is 0. Now, typically, once we've figured out, oh, this is the pattern that we're going to go, you can kind of see that at the next marker we should go up to +2. And if you don't believe me, what the original curve should have been was at a -1, and -1 times -2 is a +2. And then we're back down to 0. So a lot of times, once you figure out the initial starting point and then the very next point, you can kind of follow along the pattern, knowing that it's a wave. And after you get these points, then we can just continue our wave. So this is going to go back down to -2, up to 3 pi, which is 0. And at this one, we're going to be up at +2, and back down to 0 at 4 pi. Okay. Now, wish me luck trying to graph this thing. Okay, so we're here. Oopsies. Hand slipped. Oops, missed that one. You guys are going to do a much better job at graphing these things than I am. Okay, well, you get the idea, right? That one was actually really horrible right here. Let me do that. Just because I'm going to be a perfectionist. Here we go. Okay, so what we need to take from this, first of all, is the negative sign flipped everything about the x-axis. So instead of going up first, we went down. The 2 obviously meant we go down to 2 instead of -1. And the 0 to 4 pi means that we had to do 2 of these waves, right? Now, a question that you're going to be asked is about period and periodic functions. And what that means is your graph basically starts repeating itself once it gets to 2 pi. So once we're here, we start repeating ourselves. We're going back down again, then back up again. So at every 2 pi radians, from here to here, we get one complete cycle of our graph. And then it starts repeating itself. So when it asks you to look at a graph and figure out what is the period, you just have to look at your graph and see where it starts repeating itself. And at that point, that would be the period. So for sine and cosine, the period is 2 pi. All right, I think I've given you enough information here for you guys to work out your problems. Basic introduction to our sine and cosine curves. Good luck.